Hey folks, today we're going to talk about triangle congruence proofs. And this is what we're going to go through. And this will probably be one of the longest video you'll have from me. Okay, so let's get started. And you'll find this on the notes page under triangle congruence proofs notes. Let's start on the first one. And we're going to talk about doing a sandwich proof, the sandwich method. So let's look at what this is. We're given, this is what we're given. So it's like they're saying, here's what we start with. We're starting with this part. And what we're just going to do, we're given this piece, and this piece. It's like a puzzle. So they're starting us out with these three pieces of the puzzle put in place. So we're just going to copy those down. PQ, segment PQ, is congruent to segment ST. And the reason is, well, it was given to us. Then we have QR is congruent to TR. And they're segments. And the reason, well, it was given to us. And then R is the midpoint of PS. Why? It was given to us. Okay? The second part up here at the top is what we have to prove. Well, what do we have to prove it? Well, it's not already known. We have to prove this. That's going to go on the very last part of our proof. So we're going to put that on the last thing. And we don't know why yet. Triangle PQR is congruent to triangle STR. Now we're looking at an SSS proof, a side proof. So we know it's going to be side, but not all the time. I'm not always going to give you that. So we're not going to always know what the reason is. Okay, so let's go back to our givens. PQ is congruent to ST. So I'm going to mark that on here. PQ is congruent to ST. I'm going to put a little tick mark on there. And then QR is congruent to TR. So QR, I'm going to put 2 marks, so this is a different congruency. It's congruent to TR right here. So I'll mark it. And then R is the midpoint of PS. So I'm going to put a dot right there, a point. So now look at the bottom. At the bottom, I've got some things here. So at the bottom, I've got some choices. What have I already used? PQ congruent to ST. I've used that. R is the midpoint of it. PS. QR is congruent to TR. I've used that. I've used given 3 times. And triangle PQR is congruent to STR. Okay, so I've marked off a few things. So what do you think we need to use next? Well, in the statements, we're going to look for something that looks like symbols. Not words, but symbols. So what do you think we're going to use next? Definition of midpoint, that doesn't have symbols. Segment PR is congruent to SR. That looks like symbols, so we're going to put it next. Segment PR is congruent to segment SR. Okay, why is that? Is it by side? No, that deals with triangles. What about definition of midpoint? Well, yeah, because we were told that R is the midpoint of PS. So that means that PR has to equal RS. So that is our definition of midpoint. Okay. So now we've used that. So the only thing we haven't used is side, side, side. So now we have side, side, side. Okay. You've written your first proof. Okay. Let's try another one that's a little bit different. This next one looks similar but different. Okay. Once again, we have our given. So we're going to copy this down. We have L is the midpoint of JN, and JM is congruent to NM. We only have two pieces this time. So I'm going to put my statements. L is the midpoint of JN. It's a segment. And then I'm going to put JM is congruent to NM. Why are we putting those first? Well, we were given those. The writers of this proof gave you that piece of information. What are we trying to prove? We're trying to prove that triangle JLM is congruent to triangle NLM. And we don't exactly know why. We think it's going to be SSS, but we have to figure that out first. Let's mark our triangle. L is the midpoint of JN. So L is the midpoint. Here's L, put a dot on it. JM is congruent to NM. So JM, put a slash there, is congruent to NM. Okay. Now what can we say? Well, let's mark off what we have. JL congruent to NL. We haven't used that. L is the midpoint of JN. We've used that. JM to NM. We've used that. We've used our given twice. And we've told our triangles. So that's what we use. So now let's look and see what we've got. Can we say JL is congruent to NL? Sure. JL is congruent to NL. Why is that? Here's JL, here's NL. Why can we say that? Mark it off. Why can we say, well, look at your list here. Definition of midpoint, or reflexive property, or side, side, side. It's definition of midpoint, same as what we did on the previous one. Definition of midpoint. We mark it off. So what's left? What's the last thing? What can we say? Why just say LM is congruent to LM? Let's write it down and then talk about it. LM is congruent to LM. That's this side right here. Why? What do you notice anything strange about it? It's being shared by both triangles. So the reasoning is, if it's being shared by both triangles, it's reflexive. It's being it's reflexive property. I always thought of it kind of like reflexive and reflective, kind of similar words. So that leaves one less thing. We use those two. How are we going to prove triangle JLM congruent to triangle NLM? Well, we have side to side, side to side, and side to side. So we have side, side, side. So there's our reasons. Okay. Let's try another one. Okay. Oh, my paper. WY. Okay, so I had that chopped off. So we have our given. X is the midpoint of VZ, so I'm going to underline that. X is the midpoint of YZ, WY. So I've got two givens. So X is the midpoint of VZ, and then X is the midpoint of WY. And why can we say that? Because they were given. They were given. What's the last thing we put down? That's the top of our sandwich. What's the last thing? We're going to take our prove. We're going to come down here and say prove triangle VWX is congruent to triangle ZYX. And we don't know exactly why yet. We think it's going to be SAS. So let's work through it. Okay, so here we go. Let's go ahead and mark off what we have. X is the midpoint. X is the midpoint, and given, and do our triangle. Now, what can we say? Here's X, that's our midpoint. What can we say about WX and WXY? WX and XY. WX and XY. What can we say about those? They're congruent. And why are they congruent? By definition of midpoint. So what about, so I'm going to mark that. What about VX and XZ? This one right here and this one right here. What can we say about those? Well, they are congruent also by definition of midpoint. Can we mark those off? Yes. Here's the WX, and here is the VX, and definition of midpoint, and definition of midpoint. So now what can we say? We don't know anything about the sides out here, so we can't make that up. But we do know something about this angle 1 and this angle 2. What do we know about those angles? Look at your bottom down here. WXV is 1, and YXZ is 2. Says that they're congruent. Why? I'm going to write that down. WX angle WXV is congruent to angle what did it say? Y, X, Z. Why can we say that? Well, the reasons are vertical angles or SAS. We're not talking about sides and angles yet. We're just talking about vertical angles. So are they vertical? Here's our X, and here's what's in between. So yes, they are vertical angles. We use those two. And the only thing left is side, angle, side. Let's make sure. This angle is congruent to this angle. So I've got a side to a side, an angle to an angle, and a side to a side. Side, angle, side. So yes, side, angle, side. And so we're done. Okay, let's jump to page 5. This is another one that we're going to prove. We're going to actually do page 8, this one right here. I know they got stapled out of order. That's okay. Page 8. So this says angle, angle, side. So what do we write down first? We write down our given. We write down our given. What's given to us? Angle XWZ is congruent to angle XYZ. And how do we know that? Because it is given. Then we know that side angle line segment XZ bisects angle WXY. And what does the word bisect mean? It means cuts in half. And how do we know that? Because it is given. So now we've got our two pieces of the puzzle. Now we're going to look at the prove. We're going to put that on our last sentence down here. Triangle XWZ is congruent to triangle XYZ. And we don't know why yet. So let's mark off what we have used. Angle XWZ congruent to XYZ. We've done that one. We've done our given. XZ bisects angle WXY. We've done that one. So we've got our four, let's see. We've got one more. Oh, given. And then triangle. Where's our triangle one? There it is. Okay, so now I'm going to change colors. I'm going to go back to purple. We've got our sandwich. Now let's think about it. If XZ bisects WXY, bisects means cut in half, like a midpoint cuts in half. So here's XZ and it bisects WXY. So that means that, let's see, angle XWZ, this angle right here, is congruent to XYZ, so this angle over here. So we have those angles. What else can we say? Well, the bisect says that angle WXZ, this angle right here, is congruent to angle YXZ, this one over here. How can I say that? By definition of angle angle bisector. It's this one right here and this one right here. Okay, so now what can we say? Remember on one of them we talked about if a line is being shared with two triangles, it's congruent to itself. So XZ is congruent to XZ. I know it's silly to say. And that is the reflexive property. So XZ to XZ, and it's the reflexive property. So now we have angle, angle, side. Is that what's on our paper left? That's what's left. So our triangles are congruent by angle, angle, side. Pretty good? Okay. Let's jump to, let's see, page 10. Page 10. Okay, so I have given to me PR is perpendicular SQ and PQ congruent to PS. So let's write that down. PR is perpendicular to SQ. And why? Because it's given. PQ is congruent to PS. Why? Because it's given. Let's start with our proof. Finish up with our proof. Triangle PRQ is congruent to triangle PRS. And we don't know why yet. Okay, so let's mark our triangles. PR is perpendicular to SQ. So PR is perpendicular to SQ. So that means they're there. PQ is congruent to PS. PQ is congruent to PS. So there's those. Now let's mark off what we have down here. PQ is congruent to PS. PR perpendicular to SQ are given, and triangle to triangle. Okay, so we've got 5 things marked off. We've got 5 things written down. Okay, so what can we say about PR right here? It's a leg, isn't it? Can we say that PR is congruent to PR? Can we say it's congruent to PR, congruent to itself by the reflexive property? So PR to PR, there's that one. And there's the reflexive. And what do we know about right angles? Oh, perpendicular lines make what? Right angles. So angle QP, QRP, and angle SRP are right angles. Why is that? All right angles are congruent. So now we can say that angle QRP is congruent to angle SRP. That's a P. Okay. And that's by definition. I've got this one backwards. That's wrong. This one says all right angles congruent. This is definition of right angles. Had that one backwards. Sometimes you make mistakes. Okay, so now we have a leg. This is a leg. This is the hypotenuse. This is a hypotenuse. How do I know it's a hypotenuse? It's directly across from the right angle. Directly across from the right angle. That's how I know it's a hypotenuse. So now I can say my hypotenuse leg, my triangles are congruent. My HL. Okay? And let's see, how many more? What else do we have in here? Let's do number 12. Number 12, page 12. CPCTC proof. That stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Okay? So let's look at this triangle. On our given, we've got QS congruent to TS, and R is the midpoint of QT. So we've got two puzzle pieces. QS congruent to TS. And that's given. R is the midpoint of QT. And that is given. So QS and TS, let's find it down here. QS and TS, given. R is the midpoint, and that is given. What's our sandwich? What's the bottom of our sandwich? The prove. Angle QRS, angle, wait a minute, RQS is congruent to angle RTS. It's not a triangle this time, it's an angle. There it is. All right, so let's do our proving. Let's mark our triangle. QS congruent to TS. R is the midpoint, so there's R. What can we say about RS? Just right off the bat, what can we say about it? RS is congruent to RS. By what reason? Reflexive property. So it is got 3, well, 3, we can say 3. And we said R is the midpoint. So what does that tell us about QR and RT? QR and RT are what? Congruent. Definition of midpoint. So this one has 2. This one has 2. So they look, what do you know about the triangles now? Triangle QSR is congruent to triangle TSR. Why? Well, I've got side, side, side. So that's going to be S, S, S. Now, once I've got the triangles congruent, that means everything within the triangles matching up are congruent. So angle RQS, this angle right here, is going to be congruent to angle RTS, this angle over here, by CPCDC. And then we've got everything done. All right. So we'll do some more practice with these. Hope you enjoyed doing these as much as I did. And we'll practice some more.